Lesson 11.1b, we'll talk a little bit more about similar figures. Let's just review quickly what we learned in the last video. We have two triangles, and these triangles have a relationship between each other. You can see that there's one hash mark at angle A and D, two hash marks at angle C and F, and three hash marks at angle B and E. Remember that similar polygons are polygons where the corresponding angles are congruent and corresponding side lengths are proportional. So with these two triangles, we had triangle ABC was similar to triangle DEF, and angle A equal or is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. And the sides are proportional. AB is proportional to DE, BC to EF, and CA to FD. We have some additional exercises in the book, and sorry, I had to make a few repairs. Sometimes when I change slides, my handwritten notes fly everywhere. So we have an additional problem. Use the definition of similar polygons to show if the triangles are similar or not. Instead of having two triangles separate from each other, this is two triangles, one on top of another. And this creates a couple of unique properties. First and foremost, angle B is common to both triangles. So angle B is congruent to angle B, and we know that because of reflexive property. Now another thing that we know looking at this triangle is we have two parallel lines, line DE and line AC. And if we have parallel lines, we can consider AB and CB to be transversals, and so we can go back to our transversal properties. So angle BDE is congruent to angle BAC, and angle BED is congruent to angle BCA, and that is because parallel lines create corresponding angles. Now let's take a look at our sides, and we have on the smaller side triangle a length of 3 for BD, DE is 4.1, and BE is a length of 2. For the larger triangle, we add the values together, and BA is 6, BC is 4, and AD is 8.2. So let's set up an expanded proportion for the sides, using the smaller triangle on top and the larger triangle on the bottom. BD is to BA as BE is to BC, and ED is to CA. So those are our corresponding side lengths, and if we put numerical values in there, BD over BA is 3 over 6, BE to BC is 2 over 4, ED to CA is 4.1 over 8.2, and if each one of these is reduced, it equals 1/2. 1/2 is the K, the constant, or the similarity ratio, and because all of these sides have a ratio of 1/2, they are similar. Here's another exercise with two triangles. use the definition of similar polygons to show if the triangles are similar or not. So we don't have any angle congruency here, but we do have sides. So let's go ahead and set up the sides best we can by looking at their shapes. So let's start with the bases, and we'll take the larger triangle to the smaller triangle. So 12 to 4, 12 to 4 equals 6 to 2, and 12 fourths and 6 seconds are both 3. And then our third proportion would be 8 to 3, and unfortunately 8 over 3 is 2 2/3, so 6 seconds is not equal to 8/3, or 3 is not equal to 2 2/3, so they are not similar. A sample from the homework problems. This is homework problem number 10. We have two trapezoids. It says write a similarity statement for each pair of figures, then write an extended proportion relating the lengths of their sides. So I'm going to start at J, and this is trapezoid JKLM, and it's similar to QRSP. Now you could start anywhere you want to. You could say MJKL and PQRS. The important thing is that you have the congruency marks in the correct spots. So M and P are congruent, and L and S are congruent, and you have your parallel lines that are each alternately congruent, so they have to be in the same spot. Now we're going to write extended proportions, and you can do this by looking at each side of the triangle, but there's actually a shorter way. And sometimes you will not have a picture, sorry, I said triangle, I meant trapezoid. Sometimes you won't have pictures of the figures, and you'll have to go by information that you've got. So let's begin here. The first segment was JK, and JK is the first two letters of the smaller trapezoid. So JK is to QR. And let me just do something here and show you. So JK is to QR. Both of them are the first two letters in the trapezoids. Now the next set of proportions will be KL and RS. So KL to RS. And if you look at your figure, KL and RS are similar. Now we would have LM and SP. LM to SP. LM is the base here. SP is the base. And then the last one would be MJ and PQ. So MJ and PQ will also be compared to each other and placed in a proportion. So even without the pictures, just knowing that, just having your similarity statement will allow you to make your extended proportions. Let's look at homework number 16. We've got two triangles, the larger triangle, smaller triangle. What we're going to do is solve for our similarity ratio. And in your book, they have you, as an exercise, essentially go ahead and set up every ratio. So let's start with R, because we are solving for R. R is to 25. And then they use the next side length, which also has another variable. 12 is to S. 18 is to 30. And if this is a similar triangle, you can't reduce these two proportions, but you can reduce 18 over 30 to 3/5. So let's assume that the similarity ratio is 3/5, and now we can solve for our proportions. And the first one is r over 25, and set it to the similarity ratio. So r over 25 equals 3/5. 5 times r is 5r. 3 times 25 is 75. 75 divided by 5 is 15. And now we need to solve for s. And the ratio for this was 12 over s. So 12 over s equals our similarity ratio, 3 over 5. And now let's use cross products. 3 times s equals 12 times 5, which is 60. 60 divided by 3 is 20. So s equals 20. And if you wanted to make sure that this is true, you can set a ratio of one of these, and if r equaled 15, 15 to 25, 15 to 25 should equal 3/5. And if we divide both 15 and 25 by 5, we have 3 over 5. So that is correct. And the last problem. This is problem number 22. And this is one of the problems that doesn't have pictures. Now, if you want to try to draw pictures, you can, but you can go ahead and set up what you need without them. Given triangle LPQ is similar to triangle RST. List all known pairs of congruent angles and write an extended proportion relating the lengths of the sides. So we'll begin with the angles, and angle L will be congruent to angle R. And angle P will be congruent to angle S. And angle Q will be congruent to angle T. So those are our angles, and now we'll set up our sides. So just like we did in the previous example, LP is to RS, LP and RS. PQ is to ST. And QL is to TR. And there you have it. You won't have any values for this, but you will have all of your ratios and your angles set correctly. And sorry, one more homework exercise. This is number 26. If similar, write a similarity statement and similarity ratio. If not similar, explain why not. Well, let's take a look at these two triangles. First of all, they both share side SU. They both have congruent sides UT and UV, and they both have congruent sides ST and SV. So it says write a similarity statement. So triangle STU, I'm going with the side that has 2 hash marks, 1 hash mark, 3. So STU is congruent to SVU, 2, 1, and 3. And the similarity ratio for this two pairs of triangles is a little different than the other ones because, first of all, we have no values to compare, but we do know that they're congruent. And because they are congruent, we're saying that they are equal. So our similarity ratio would be 1. And how do we get that 1? Well, if TU was 3, that would mean UV would be 3. And if TS was 4, that would mean that UV was 4. And whatever number is here would be the same number here. So if you were to write comparative ratios, you would have 4 over 4 and 3 over 3 and 6 over 6, which equals 1. Hope that helps. Let me know if you have any difficulty with your homework. You'll be doing problems 9 through 15 odd and 19 through 25 odd. And we'll talk to you again in lesson 11.2.